Hi everyone. This part of the presentation on density is specific to doing the Density of Pennies lab. So the idea behind this lab is that not all pennies are actually exactly the same. Before 1982, we used to make pennies mostly out of copper. They were 95% copper, but the inside had a little bit of zinc. It was 5% zinc. After 1982, they realized that the price of copper has gone up so much that it cost more than 1 cent to make a penny, which is a little bit ridiculous to spend more money making the money than it's actually worth. So at that point, they increased the amount of zinc so that the penny is almost entirely zinc, and the copper part we see is actually just a thin foil of copper on the outside. So it's only 2.4% copper and 97.6% zinc. Because copper and zinc are different materials, they have different densities. So the pre-1982 pennies versus the post-1982 pennies will have different densities, and the lab is about trying to find out what the density of each type of penny is. So a couple of lab things we're going to be needing to be able to do. We need to be able to use a graduated cylinder. When you pour liquid into the graduated cylinder, we'll be using water. You're going to see that it makes a meniscus. A meniscus is the curve that you see here, because the water is clinging to the sides of the graduated cylinder a little bit. There's some attraction between the molecules, and it causes it to curve. It's very, very important that when you read your graduated cylinder, you read it from eye level, right at the bottom of that meniscus. You don't want to be way up here looking down at it, and you don't want to raise it up in the air and try to look at it from down here. That's going to really alter where your eye sees this line. So reading from the bottom of the meniscus is really important. Another technique that we're going to use for this lab is called water displacement. Because a penny is not a perfectly uniform shape, it's really difficult to measure the true volume of it. So what we'll be using is something called water displacement. So we will have a known amount of water. In this picture, we're going to use 10 milliliters of water. We're going to dump our weird shaped object into the water, and it's going to displace the water out of the way and take up some space in there as well. And so what we can do is we can see how much the water went up to 30 milliliters, and we can subtract where it started, and the amount of difference is the volume of the weird shaped object. So for this lab, because a penny is really small, you're not going to measure one at a time. You'll put in like 10 pennies at a time and see how much space 10 pennies take up. And so we'll get a much bigger number. It'll be a little bit easier to read. We will also be calculating the percent error. On the lab handout, I will tell you what the correct value is. The correct value is what we call the accepted value. Your value is the one that you get during the lab. And remember, these vertical bars mean absolute value. We don't really care if it's plus or minus. We just want to make sure that we get our subtraction, take the absolute value of it, and divide it by your accepted value again. And we'll be able to see who got the closest to the correct answer. In class, we'll write all of our results up on the board. We'll see who got the best value for pre-1982 pennies. We'll see who got the best value for post-1982 pennies. And we'll kind of be able to see, how far off were the other values, and maybe come up with some brainstorm ideas on sources of error and what could have caused somebody to get a number that was too high, or what could have caused somebody to get a number that was too low. All right, that's it for this video. I hope it was helpful. Bye, everybody.